Hello, Assalamualaikum. My name is Muhammad Mohamin bin Ahmad Fazri. Number metric is CE200124 and members group name is Muhammad Nur Hidayat bin Muhammad Ismail. CE200142 Muhammad Amir bin Cik Alaha. CE200161 Muhammad Haikal bin Azmi. CE200123 and Muhammad Firdaus bin Muhammad Fauzi. CE200192. And we are from group 3. Today we will present about the project from the subject BEJ20203 Signal and Systems. We learn about the Fourier series and we will explain what we get from this project. For the question 1, we learn about Fourier series expansion. The first step is we calculate time. The formula is 1 over frequency, so 1 over 55k, and we get the answer is 0.18 millisecond. Then we calculate W0. The formula is 2 pi f, so 2 pi 55k, and we get the answer is 110,000 pi. For the next step, we calculate A0. The formula is 1 over t integrals torque and 0 x time t dB, and we get the final answer for A0 is 8.333 millitorque. The next step is we calculate An. The formula is 2 over t bracket integrals torque per 2 and 0 cos n W0t dt plus integrals torque and torque per 2 cos n W0t dt. And we get the final answer for An is 1 over pi n bracket 2 sin n 110,000 pi torque minus sin n 55,000 pi torque. Next, we calculate Bn. The formula is 2 over t bracket torque and 0 xt sin n W0t dt. And we get the final answer for Bn is 1 over n pi bracket 1 minus 2 cos n 110,000 pi torque plus cos n 55,000 pi torque. And lastly, we'll calculate xt. The formula is A0 plus summation infinity n equals 1 an cos n W0t plus summation infinity n equals 1 bn sin n W0t, and we get the final answer is 8.333 millitorque plus summation infinity n equals 1 bracket 1 over n pi bracket sin 110,000 pi torque minus sin n 55,000 pi torque close bracket times cos n W0t plus summation infinity n equals 1 bracket 1 over n pi bracket 1 minus 2 cos n 110,000 pi torque plus cos n 55,000 pi torque. That's all from me for the calculation question 1. Thank you.
Assalamualaikum and hello. Thank you my friend Mohamin for your presentation before. Now, I'm Muhammad Amir bin Cik Alaha with metric number CE200161 will present about our coding for task 1. First, before we make a coding for task 1, we need to know what frequency we want to use in this coding. For our project, we use 55 kHz for our frequency. So our T in this coding is 1/55 kilo. Then we need to know what a harmonic we want to get the graph. This question want us to use the harmonic value is the 5, 10, and 20 for our harmonic. So we make a coding in that value. Lastly, is we need to compare three graph, which is harmonic graph, time domain graph, and frequency graph. As you can see at the next slide, first graph is harmonic graph, left top is a time domain graph, and bottom is frequency graph. That's all from me. Now I will pass to another my friend to the task 2 and calculation 2. That's all from me. Thank you.
For the question 2, the cutoff frequency is 4 times the frequency of the signal, and the frequency is 55 kHz. For the cutoff frequency or FC, 4 multiply frequency, 4 multiply 55 kHz, and we get the answer 222 kHz. For the frequency sampling, Fs, 10 multiply 220 kHz, we get the answer 2200000 Hz or 2.2 MHz. For the angular frequency, F frequency, cutoff frequency, divide frequency sampling, divide 220 kHz, divide 2.2 MHz, divide 2, and we get the answer 1 per 5 Hz or 0.2 Hz.
Hello, Assalamualaikum. My name is Muhammad Firdaus bin Muhammad Fauzi. My matrix number is CE2 for simulate. This is my part is question 2. Question is construct a low pass filter as in figure 2A using software MATLAB with frequency response characteristic given in figure 2B. So this is my output result using MATLAB software. The first thing of recording is Fs. Fs is frequency sampling. This is 2200000, which is 2.2 megahertz. Fc is frequency cut-off frequency, is 220 kilohertz. And then W equal to Fc over Fs over 2 is a normalized frequency. And then BA equal to butter 1W low, and then HW equal to frequency BA 1000. And then for the wave graph, just put plot W times pi dot times Fs over 2 20 dot times log 10 ABS H comma K, and then you got the output of the graph. This is the output of our graph. That's all from me. Thank you.
Hi, Assalamualaikum. My name is Muhammad Nur Hidayat bin Muhammad Ismail. My matrix number is CE2000142. Hi, today I will present my signal project. So my part is the task 3 where we need to determine the output of the frequency after entering a filter. So here, this is the command in MATLAB or coding in MATLAB. As you can see, there is FS, FC. FS is sampling frequency, and for FC is cutoff frequency. The function of max range is to set a range to a subject. Okay, so T is a subject, X is a subject also. For X underscore max, the command is used to develop the frequency spectrum. Okay, the number bin here, the number bin is a storage that we can also call the storage. Okay, and then you can see here X filter. X filter is to beautify the output, the graph, the output in the graph. And then you can and then like the lastly you can see here y underscore max. This one is a command that used to develop magnitude spectrum. Just now this one x max is to develop frequency spectrum. This y max is to develop magnitude spectrum. So on the right side you can see the filter signal, the upside, and the downside is the impulse that been created after entering the filter signal. That's all from me. Thank you.